ኦኬ ሄሎ የተከበራችሁ የዚህ ቻናል ቤተሰቦች እንኳን ወደዚህ ቻናል በሰላም መጣችሁ። እኔ ጌታሁን ሶርሳ ነኝ።
በዚህ ቪዲዮ ላይ የሚለቀቀው የቱርቦ ማሽነሪ ሁለተኛ ፓርት ነው። የመጀመሪያ ፓርት በባለፈው ሳምንት ቪዲዮ ከጥያቄ ቁጥር ከ1 እስከ 13 ሰርቼ አፕሎድ አድርጋለሁ። ይህን ቪዲዮ ከመጀመራችሁ በፊት ቁጥር 1 ፓርት 1 ለማየት ከፈለጋችሁ በዚህ ቪዲዮ ከታች በዲስክሪፕሽን ቦክስ ላይ ሊንኩን አስቀምጣለሁ። የፓርት 1 ሊንክ እሱንም እንድታዩ እና ካያችሁ በኋላ ለሌሎቹ ሼር እንድታደርጉ ነው። አሁን ቀጥታ ወደ ጥያቄዎቹ እናልፋለን።
ቁጥር 14 the change of angular momentum of liquid passing through the runner of the pump causes A. pressure rise of the liquid, B. change in linear momentum of the liquid, C. pressure drop through the pumping system, and D. loss. So when we are changing or when the change of angular momentum of the liquid occurs, what happened on the runner of the pump? So in this here there is 4 choices, and to select the correct answer, the change in angular momentum of the liquid passing through the runner of a pump causes a change in linear momentum of the liquid. So the correct answer from this description is choice B, change in linear momentum of the liquid. So when there is change of angular momentum of liquid passing through the runner of the pump, it causes change in linear momentum of the liquid also. So B is correct answer. Okay. The next question is the process of filling the liquid into the suction pipe and pipe casting up to the level of delivery valve is called A. filling, B. pumping, C. priming, D. leveling. So what the process when we fill the liquid into the suction pipe? So similarly, let us see the description or the discussion. So when we fill the liquid into the suction pipe and the pump casting up to the level of the delivery valve to remove air and allow the pump to operate properly is what we call it priming. So the process is priming process, and it is essential to ensure that the pump is filled with the fluid it is supposed to pump, preventing air pockets that could affect the performance. So that process is what we call it priming. So the correct answer is here choice C, priming. So this is correct answer. Okay, let's go to the next question. That will question number 16. The ratio of actual wheel velocity to the ideal wheel velocity in the centrifugal compressor is called A. velocity factor, B. slip factor, C. work factor, D. none of the above. So which one is the ratio of actual wheel velocity to the ideal wheel velocity in the centrifugal compressor? So here we have also similar discussion for this specific question. When the ratio of actual wheel velocity to the ideal wheel velocity in a centrifugal compressor is called slip factor. So this choice B is correct answer for this question. So the correct answer is slip factor. The ratio of actual wheel velocity to the ideal wheel velocity in the centrifugal compressor is called slip factor. So this is correct answer. And the next question is H can be defined as the ratio of pressure rise in rotor blade to the pressure rise in the stage in an axial flow of compressor or an axial flow compressor. A. degree of pressure, B. degree of reaction, C. pressure ratio, D. reaction ratio. So which one is correct answer for this question? Which one could define the ratio of pressure rise in the rotor blade to the pressure rise in the stage in the axial flow compressors? So to select the right answer or correct answer, similarly we have to describe or explain it. Here, the degree of reaction in axial flow compressor is defined as the ratio of the pressure arise in the rotor blade to the total pressure arise across the entire stage. And it is a parameter used to describe the distribution of pressure rise between the rotor and the starter blade in stage of the compressor. So the correct answer for this specific question is answer B, degree of reaction. Degree of reaction. So degree of reaction can be defined as the ratio of the pressure rise in a rotor blade to the pressure rise in the stage and axial flow compressor. So this is correct answer. Okay, when we go to the next question, the passage of uniformly varying cross section in which the kinetic energy of steam increase at the expense of its pressure is called A, steam nozzle, B, steam turbine, C, steam area, and D, all of the above. Okay, so let us see the explanation for this part. And the passage with a uniformly varying cross section in which the kinetic energy of steam increase at the expense of its pressure is called steam nozzle. So the correct answer is this part, choice A, steam nozzle. So the pressure of uniformly varying cross section in which the kinetic energy of steam increase at the expense of its pressure is called steam nozzle. So correct answer is A. Okay, the next question. A pair of fixed blade and rotor blade in axial flow compressor is called A, step, B, pair, C, stage, D, state. So in axial flow compressor, a pair of fixed blade and rotor blade together is referred to as stage. And in each stage, the compressor contributes to the overall compression of the air. So the correct answer is C, which is stage. So this C is correct answer for this question. Okay, the next one is an axial flow compressors have A, disc type rotor, B, drum type rotor or disc type rotor, C, drum type rotor, D, none of the above. So for axial compressors or for axial flow compressors, which type of rotor is applicable? A, disc type rotor, B, drum type rotor or disc type rotor, C, a drum type rotor, and D, none of the above. So for this here, axial flow compressors, they can have either drum type rotor or disc type rotor. So this axial flow compressor may have either drum type rotor or disc type rotor. Therefore, the correct answer is choice B. This choice B is correct answer for this specific question. Let's go to the next question. Which of the following is an example of impulse turbine? Which of the following is an example of impulse turbine? A, Pelton wheel, B, propeller turbine, C, Kaplan turbine, D, Francis turbine. So from this option, which one is an example of impulse turbine? Okay, so in this, when I explain the correct answer, this Pelton turbine is correct answer for this question. And these Pelton wheel turbines are particularly well suited for this high level or high head, low flow applications. So the correct answer for this question is choice A, which is Pelton wheel is correct answer. This is correct answer for the question. So Pelton wheel is an example of impulse turbine. Okay, the next question is, which of the following is not a type of positive displacement pump? Which of the following is not an example of or not positive displacement pump? A. Rotary displacement pump. B. Centrifugal pump. C. Reciprocating pump. And D. None of the above. So the correct answer for this question is answer B, or choice B, which is centrifugal pump. So this is not positive displacement pump. Or they are dynamic pump, especially classified as kinetic pumps. Okay, this choice B is correct answer for this specific question. So this reciprocating pump is positive displacement pump, and the rotary pump is positive displacement. Let's go to the next question. Dash component of fluid velocity have the responsibility of the transportation of fluid through the machine? A. Tangential and axial. B. Radial and tangential. C. Radial and axial. D. None of the above. The correct answer is the radial and axial components. So the radial and axial components of fluid velocity are responsible for transportation of fluid through a machine, such as pump or turbines. Let's move to the next question. The product of force F and time T is called A. Work done. B. Momentum. C. Impulse. D. Pressure. So to answer this question here, the correct answer is impulse. And this impulse is the product of force and time. So mathematically, it is calculated as I is equal to F times T. And it is also a vector quantity, and it is related to the change in momentum of an object. So the correct answer for this question is impulse. So impulse is the product of this force and time T. The next question. Suction head is A. Is the distance from the surface of water delivered in center of pump. B. Its head against which centrifugal pump has to work. C. Is the distance from surface of water to be lifted in center of pump. D. Is the head at the pump inlet. E, C, and D are correct answers. So which of these best describes this suction head? So the correct answer is C. It is the distance from the surface of water to be lifted in the center of the pump. So it is the vertical distance from the surface of the liquid to the center of the pump, and it represents the height the pump needs to lift the fluid from its source to the pump inlet. So the correct answer is suction head is the distance from the surface of water to be lifted in the center of the pump. C is correct answer. This C is correct answer for this specific question. The next question is, which of the following is not the loss on pipe? A. Friction loss. B. Elbow loss. C. Cross-section change loss. D. Impeller trip leakage. So this is not the loss on pipe. So to choose this is the correct answer, also we have to see the explanation. So the correct answer is D. Impeller trip leakage. This is not loss on pipe. It is typically associated with turbomachinery such as pumps or compressor, and is not a loss directly related to the pipe. So in this question we have asked that the loss which is directly related with the pipe, but this impeller trip leakages, it is directly related with the loss of pump or compressor rather than that of the pipe. So the correct answer for this question is choice D. Choice D. So this one. Impeller trip leakages, it is not loss which is directly related with the pipe, but friction loss, elbow loss, and cross-section loss are directly related with loss on pipe. Let's go to the next question. The function of diffuser is A. To accelerate the fluid from its initial condition to the entry of inlet guide vanes and to provide uniform velocity at the end. B. It is to direct the flow in the desired direction at the entry of the implant. C. Function of this diffuser is to increase the energy level of the fluid by whirling it outward by increasing the angular momentum of the fluid. And D. It is used to convert the high kinetic energy of the fluid at impeller outlet into static pressure. So which of these the listed option or choice is the function of diffuser? So the primary function of diffuser in the center for the compressor or pump is to slow down the fluid and convert its high kinetic energy obtained at the impeller outlet into static pressure. So the correct answer is D. The diffuser is used to convert the high kinetic energy of the fluid at impeller outlet into static pressure. So D is correct answer for this question. So this one is correct answer. Let's go to the next question. The pressure ratio can be obtained from a single stage compressor manufactured using conventional materials. What is the pressure ratio which can be obtained from a single stage compressor which is manufactured using conventional materials? A. 4:1, B. 3:2, C. 5:1, D. None of the above. The pressure ratio which can typically obtained from a single stage compressor manufactured using conventional material is 4:1. Therefore, the correct answer is choice A. Is the first choice. This one is correct answer. The pressure ratio can be obtained from the single stage compressor manufactured using conventional materials 4:1. So this is the correct answer. Let's move to the next question. An axial flow compressor is usually designed to have multi-stage. Why? A. Because of small pressure ratio that can be attained in single stage. B. Because of small change in angular momentum of the fluid. C. Because of low tip velocity of the blade. D. None of the above. So to see the correct answer for this, usually these axial flow compressors are typically designed with multi-stage because of achieving a large pressure ratio in a single stage would be require a very high blade speed, which may lead to practical and engineering challenges. By dividing the compression process into multi-stage, each stage can contribute a smaller pressure rise, which allow for more manageable blade speed and improve efficiency. So it's a small pressure ratio that can be attained in single stage. Small pressure ratio can be attained in single stage, and to obtain large pressure ratio, we have to arrange these axial flow compressors in multiple stages. Therefore, the correct answer is A. We arrange these axial flow compressors in multiple stages because in a single stage, small pressure ratio can be attained. So to have high pressure ratio, we have to arrange these axial flow compressors in multi-stage because in single stage, small pressure ratio is attained. So to increase the pressure ratio, we have to arrange these axial flow compressors in multi-stage. Okay, the next question is, one of the following is disadvantage of hydropower plant. A. Eco-friendly. B. Slow rate of change. C. Site inconvenience limit applicability. D. Lower operation and maintenance cost. For the disadvantage of hydropower plant is usually related with the site inconveniences. So the disadvantage of this hydropower plant is generally associated with site inconvenience that limit its applicability. So the correct answer for this question is choice C. The disadvantage of this hydropower plant is, it is side inconvenience which limits applicability. So this is the disadvantage. Let's move to the next question. So which one of the following is not classified under impulse type hydraulic turbine? A. Pelton turbine. B. Turbo. C. Cross flow turbine. And D. Kaplan turbines. So in impulse type hydraulic turbines are those in which the energy of the water jet is entirely converted into kinetic energy before it strikes the blade of the turbine. And some of the examples of this impulse type turbines are Pelton, Turbo, and cross flow turbines, which fall under this category. And this Kaplan turbine is, on the other hand, it is a reaction type hydraulic turbine. It is reaction type hydraulic turbine. And in this type of turbine, the water both enters and leaves the runner under pressure. In this case, water enters as well as leaves into the runner under the pressure. And the Kaplan turbine is especially is a type of axial flow reaction turbines. So the correct answer is the Kaplan turbine is not classified under impulse type hydraulic turbine. Let's move to the next question. So if a mechanical efficiency and manometric efficiency of centrifugal pumps or pump are 62% and 70% respectively, then the overall efficiency of the pump will be A 0.4464%, B 4.464%, C 0.044%, D 44.64%. So we have given here, we have the mechanical efficiency, which is 62%, and manometric efficiency, which is 72%. So by using this, we can calculate overall efficiency of the pump. So how we can calculate the overall efficiency? Simply, we can calculate this overall efficiency, which is as the product of this mechanical efficiency and manometric efficiency. And when we multiply this 0.62, this is simply multiplying 0.62 with 0.72, and the correct answer is 0.4464. When we express this in terms of percent, which is 44.64%. The correct answer is D here. This D is correct answer. For the operating point of pump, the system characteristics between the head edge, which is required, and the discharge to be maintained, QO, is generally expressed as A. Linear equation, B. in form of parabolic equation, C. in form of exponential equation, and D, which is in form of cubic equation. So the correct answer for this question is, which is in form of this parabolic equation. The next question is, one of the following is not classified under rotary type pump: A. gear type pump, B. lobe pump, C. screw pump, and D. centrifugal pump. So here we have classification of rotary pumps. Basically, rotary pumps are classified into four basic categories. These are screw type pump, gear type pump, lobe type pump, and vane type pump. Here we have screw type pump, gear type pump, and lobe type pump. So this centrifugal pump is not classified under this rotary pump. So the correct answer is D. The centrifugal pump is not classified under rotary type of pumps. When we come to the next question, this question is the last question for this video. And here, what is the function of pump? What is the function of pump? A. to transfer liquid from one place to another place. B. to circulate liquid around the system. C. To lower water from higher surface to the ground. D, A, and B are correct answer. So what's the function, or which one of this best describes the function of pump? So here, when we say pumps, they are mechanical device. They are mechanical device that use energy to move fluid from one point to another. So this is the definition of pump. And we have function of pump here. The functions of, or the primary function of pumps are to transfer fluid between 2 points, to produce required flow rate, and to produce required pressure. So in this, from this choice, the function of a pump include both transfer of liquid from one place to another place and circulate liquid around the system. These two are the correct answers. So the correct answer for this question is choice D. Both A and B are correct answers. Both, this D is correct answer. Both A and B are the primary function of pump. Okay, so this is the question that I have regarding this turbo machinery exit exam or model exit exam, and I will come with the other part. So if you are new for this channel, you have to subscribe and to be a member for this channel. And thank you for watching this video.